So the iceberg has weight, mg, and the buoyant force is equal to make it float, right? That's what we said. So an iceberg is floating. Most of the iceberg, I don't know why I drew it egg-shaped. It's an egg-shaped iceberg. Most of it is underwater. What's going on here? What's balancing out? What's happening for it to be equal? What's the net force for it to not be moving? I meant to write MA. That's what's confusing about this. MA is equal to 0. No acceleration, so the net force is 0. If we have what's holding it down? So I've got gravity. My net force is made up of mg, and what's keeping it up? Okay, and that's balanced by the force buoyancy, and that's what's equaling 0, right? Yeah. All right. Well, why don't we move one to the other side? The force buoyancy is equal to mg. This is the iceberg, right? The mass times gravity of the iceberg. Mm-hmm. And the buoyancy is actually supplied to us by what? Rho Vg. And this is of the water. The iceberg, you could think about this as being rho Vg of the iceberg as well. Right? Mass is equal to density times volume. All right. Well, if we rearrange this, well, first thing, gravity cancels out. But if we rearrange this, we start to see that the volume of the water compared to the volume of the iceberg, that's the water the iceberg is displacing. Well, that's the percentage of the iceberg that's being displaced, right? If I took this ratio, could also be seen as the density of the iceberg versus the density of water. That's just this equation rewritten, but now we have a ratio of the water to iceberg, what percentage of the iceberg is underwater, versus, oh man, a comparison of two densities. What was this called?
Specific gravity.
Specific gravity. We know that the specific gravity of ice is 0.917 grams per centimeter cubed. So that's 0.917 grams per centimeters cubed over 1 gram per centimeter cubed of water. That's the density of water versus the density of ice. So we actually know the percent of ice that sticks out of our drinks. It's about the leftover 8.3%. It's okay. So over 90% of iceberg's volume is underwater because about 91.7% is underwater. Okay. The fraction of ice underwater is given by the ratio of the densities. And over 90% of the iceberg's volume and mass is underwater. The underwater fraction of the substance floating on water is given by that substance's density. Okay.